Hi there and welcome back. This is chapter 12 of the DB2 course, our discussion of join algorithms in relational database systems. So the last three videos have been spent with the nested loop join, or its variant, the block nested loop join, or the efficient index nested loop join. So let's call it the day for the nested loop join in the context of this course. Let's move on to the next join in the join algorithm family. That would be the merge join, which is a specialist in evaluating equi-join conditions. Can be very efficient given that the input tables satisfy a number of constraints or restrictions. Okay. All right, so as I just told you, the merge join is actually only applicable in situations where the join predicate is indeed an equality predicate. So we are looking at an equi-join here between a left and right input. And let's assume that the CL would be the join column of the left and CR would be the join column of the right input. Okay, well, the footnote says that in the meantime, there have been adaptations to the merge join idea that will also work for comparisons that are not equality, but would also work for, say, less than or less or equal. We will not discuss these in the course of this chapter. Have a look at the literature. You will find that the basic ideas that we discuss here will stay the same, but the devil is in the gory details. Some adaptations have to be made there. But the grand idea of merge join is something that we will cover in the next two videos, I think. Okay, as I already said in the beginning, well, there are some restrictions, some constraints on the left and right input tables to the merge join, so that merge join indeed becomes applicable. And well, there is a very strict condition on the left input. It indeed must be sorted on CL, which is the join column. Okay, so an ascending sort order on the left input regarding the CL column must be provided. Asymmetrically, the right table input must be sorted on the CR column. So both are being sorted on their join criteria. What will merge join do? Well, it will scan the left input once only in order of ascending CL values. It will also scan the right input once. Well, with an asterisk, we will come to that. But essentially, the right input will only be scanned once, of course, also in ascending CR order. So this is a fundamental difference if you compare this to the index nested loop join, where the inner input would be scanned repeatedly, right? Or the index scan would have to be performed repeatedly. In the case of merge join, we are aiming for a single scan of the left and a single scan of the right input. We will see in the details of merge join that indeed the right input has to support or has to admit a rescanning of rows. So at points, we will have to reset the scan pointer in our top to bottom scan of the table. And we have to reset the scan pointer a few rows, maybe a few more rows, hopefully not too many rows, have to scan the scan pointer back and rescan a portion of the rows of the right input multiple times. But well, we would hope that this rescanning only affects a few rows, maybe a few blocks, a few pages of the right input, and thus would be local. It does not ask for a complete rescan of the right input. And this has been the case in the nested loop join algorithms. We try to avoid that here. Okay, so there are some restrictions on the sort order of the inputs, but there will be a guarantee on the sort order of the join output. It will be ordered on the CL column and thus also on the CR column, because both are required to be the same regarding the join condition. All right, so sorted inputs, sorted outputs. And well, this makes merge join a very good candidate in larger query plans that really require particular row orders. So if you consider a group by that would be evaluated after such a merge join, well, that group by could rely on the on the output that is delivered by the merge join to be sorted on the CL or CR column. If CL or CR is not only participating in the join predicate, but would also be a grouping criterion or maybe a sort order criterion, well, then the merge join could deliver the rows essentially in the ideal order for such a group by or order by. Maybe it will turn an order by into a no-op. Actually, this is such an important concept. The construction of row order as a byproduct of the evaluation of other query operators, join for example, that this is a concept that has become its own name in query processing. It's called the interesting orders, and they will pop up later in this particular chapter, and they will also pop up when it comes up to query optimization later on. All right, but first focus on merge join. How does merge join function internally? How does merge join behave? There are some ingredients that we need to describe the behavior of merge join. And when you see such arrow symbols on this slide, like this one, or this one, or this one, or even this one, then these arrow symbols refer to the next slide, slide 14 in this particular set. So look at this slide for an explanation of what you will see on the upcoming slide, which we will of course discuss in this video, just to make sure that you interpret these arrow symbols correctly. All right, so what you will see on the next slide is a trace of how merge join indeed scans its both inputs, the left and right table input. You will see that it maintains row pointers, individual row pointers for the left and right table. All right, so that would be the pointer into the left, that would be the pointer into the right input table. And they are both independent. Both can move independently in both their tables. They are independent, but merge join will move them forward in lockstep. Whenever the merge join will find that the left input or the value in the row pointed to by the left pointer in the join column is less than the join value in the right, in the current row in the right hand input table, then it will move forward leftmost pointer, right. So if the right-hand side value in the current row of the right-hand side table is larger than that in the left-hand side table, then let's move forward the right-hand side pointer. So both will move in lockstep, and we'll try to find rows in both tables in which actually the CL and CR values in the current rows in both inputs are the same. If this is the case, well, then we have found a row that can be emitted into the join result. All right. And you will see that the algorithm will sometimes remember the position of the right-hand side pointer in the right-hand side table by setting such markers. That would be a marker that marks a remembered position. The right-hand side pointer may move further downwards the table, but we will see that there are situations when the right-hand side pointer will be resetted to this marker, to the remembered position. When this happens, we will see in the trace this particular symbol that sends back the right-hand side pointer to the marker in a sense, so that it can rescan a part of the right-hand side input. Okay, so this is the limited rescanning that we've already discussed. So I think the explanation on slide 14 may fill all of this with some more insight. So let's see. Right, so this is our merge join situation. And indeed, as you see, there is a left-hand side and a right-hand side input table, all right? They have, of course, the CL and the CR join criteria columns. Okay, there might be more columns. I have only indicated them slightly here and not shown them here. They are not relevant to our particular discussion. All right, so both tables might have more columns, but only CL and CR are indeed relevant for what we are going to display here. As you can see, indeed, both inputs are sorted on their CL and on their CR columns. Some values might, of course, be duplicates here, but the sort order in both of these columns is ascending, strictly ascending. All right. As indicated already on the previous slide, there are left and right hand side read pointers that are maintained in the left table and in the right table. Both start at the beginning of the table here. All right, so let's see what happens. How does merge join do its job here? All right, so here in this situation, we would look at the CL and CR values, and we would see that the CL value is less than the CR value, the current CR value. So we will advance the left-hand side pointer in our search to find CL values that are equal to the CR value. And this is what happens here. We have indeed advanced the CL pointer. What we now see is that the CL and the CR values are indeed the same. All right. This is the point in time where we will save the position of the right-hand side pointer as indicated by this marker symbol. Okay. Since we have found two pairs of rows that agree in their CL and CR values, we will emit a row and then advance the right-hand side pointer. Okay, so the right-hand side pointer has indeed reached this row with the key value or the CR value 3. All right. Well, in this situation, CL and CR disagree again, and CL is less than CR. So we will move forward the CL pointer. All right. So as you can see, CL and CR agree again. So it's time to save the position, the current position of CR. It has been saved here, as you can see. Emit a joined row and then move forward the CR value. All right. As you can see, well, CL and CR are again equal. So it's time to emit another joint pair. So indeed, this would be this and this particular row that would be emitted into the join result. Okay, now it's time to move forward CR again, and we end up in this particular situation. Okay, so CL is indeed less than CR again, so it's time to move forward CL. So we continue our trace here. All right, CL and CR are the same again. So what we will do is we will emit a joint row and we will save the position of CR. Okay, and then move forward CR. Another match has been found. This row and this row both agree in their CL and their CR values. One more row to be admitted into the result. It's time to move forward the CR pointer again. All right, and you see that indeed it has hit EOF here at this particular point. At this point in time, it's time to move forward the CL pointer. There is no way we can move forward or compare anything within the CR column here. So it's time to move forward the CL pointer. So from here to here. Okay, and what we now find is a new situation. In the CL column, we indeed found a repeating group. We had the CL value 4 before, this value. Now we've moved forward the CL pointer and we found the same CL value again. This is a repeating group of values, CL values here in the left-hand side table. At this point in time, it's time to reset the right-hand side pointer. To reset the right-hand side pointer, and this is the symbol, to its saved position. And as you can see, indeed, the right-hand side pointer has been reset. This is the limited rescanning that we have mentioned already. The right-hand side pointer has been reset to the marked position, and it's now time to emit joint pairs again. So this 4 joins with this 4. Okay, one more result in the output, and it's time to move forward CR. Right, this is what we've done here. Again, a new joint partner. 4 and 4 do match. So indeed, a new joint partner has been found and will be emitted. It's time to move forward CR. All right, this is where we are now. All right, at this particular point in time, well, we would finalize our joint processing because no more matches can be found here. But well, this is the synchronized lockstep advancement of pointers in the left-hand side and right-hand side tables, and on the encountering of a repeating group, of a repeating group of values in the left-hand side column here, reset the right-hand side pointer to its marked position to rescan, to perform a local rescanning of the rows here on the right-hand side. Well, of course, both of these rows with a 4 in the left-hand side column have to join with all the 4s on the right-hand side here. And the reset and the rescan, this local rescanning, of course, ensures that the semantics of the join are being maintained. So this is the idea of the synchronized pointer movement in merge join. And as you can see, indeed, the left-hand side table is scanned only once. The pointer is strictly moving forward, right? This pointer. On the right-hand side, this pointer is almost strictly moving forward. At some points, there will be local rescanning going on. Of course, the worst case will happen if all the values in the left-hand side column constitute a large repeating group. Okay, in this case, we may find ourselves to compute a Cartesian product. That would be the worst case that can hit us. We find the match already at the beginning here. We would set the marker in the right-hand side at the very beginning. We would scan the entire right-hand side table to emit or look for join partners. And since the entire left-hand side column is entirely filled with repeating CL values, it's one large repeating group. At the end of our CR scan, we would have to reset to the very beginning of the CR table again. But well, this is of course a corner case that is not very likely and not happening often in true workloads. This is the pseudocode that would describe the behavior of merge join. So let's have a quick look here. What you will have is, of course, the left and right-hand side inputs. I think it's not appropriate to talk about inner and outer inputs here. Both are in a sense on the same level. Both are being scanned once, while the right-hand side might be rescanned locally. All right. What we need is the left-hand side and right-hand side join columns. You see that we don't have the theta, the comparison relationship in the API of our merge join here. We expect to be performing an equijoin here. So no need to actually receive the comparison predicate theta as an argument here. Okay, again, we would construct the join result j and later on emit j once we have performed our computation. All right, and well, these left and right arguments, we would interpret them as the arrow, the pointers that we maintain while we scan our left hand and right hand side input tables. All right. As you can see, there is an outer loop here that would check that we have not reached the end of table in any of these input tables. Okay, while this is the case, while there is even the chance to produce more join pairs, well, we would then compare the CL and CR values in the left hand and right hand side tables and would advance in the left hand side if CL is indeed smaller. We would advance in the right-hand side if indeed this right-hand side is smaller. Of course, we are on the search for rows, pairs of rows in both inputs that have values CL and CR that are equal. Okay, once we reach this particular point in the code, we would then save the current position of the right-hand side pointer inside this marker. Okay. And then we would check whether we indeed have reached a pair of rows where the left-hand side and the right-hand side agree in their CL and CR values. Okay, but should this not be the case, then we will skip this entire piece of the code where we will construct join outputs and just return to the top of the loop, where you can see that we would continue with the advancement of our left and right pointers on our search for join pairs of equal CL and CR values. Okay, so if we indeed have found such a pair, then we will enter this piece of the code that we have just skipped. All right. So this outer while loop in this particular piece of code, this is responsible for the rescanning, for the resetting. You see that at this particular point, we will read the marked position back into the right-hand side pointer. If we enter this loop for the first time, well, then the marked position has been just the right pointer. So this is actually the a no-op with the respect of the right-hand side pointer. It will just maintain its value. On every rescan of every re-entering this while loop at this particular point here, at this particular point, we will indeed reset the right-hand side pointer to the marked position. Okay, so that's exactly what we needed. Perfect. This is the join condition that we were hoping for. So have a pair of left and right values that rows that indeed agree on their CL and CR values. If we have found such a pair, then it's time to emit a join pair into the join result, and CR would be advanced. Right, we will do that and emit new join pairs while we indeed will find join pairs in the current left and the current right row. At one point, we will have exhausted all the right-hand side values that agree with the current CL values. At this point, well, we would then advance the left-hand side value, the left-hand side pointer, and then check whether we are in a repeating group. If this condition is fulfilled at this particular point in time, we have hit a repeating group. We have advanced the left-hand side pointer, and we are still looking. At CL values that agree with the CR values. So this is the indication of a repeating group. And if this is the case, well, then indeed we will reset the right-hand side pointer and start the rescanning of the right-hand side to emit more join results. If this is not the case, then well, we either have no repeating group or we have reached the end of the repeating group, and it's back to the main loop here that we will pursue until one of the inputs has been exhausted. All right, so this is a nesting of 5 while loops, and I'm fully aware that this is not something that you can wrap your head around while just listening to me talk about this piece of code. I can only invite you to take a sheet of paper and a pencil, and then maybe replay the movement of the left and right pointers, the setting of the markers, the resetting of the right-hand side input to its marker. Just replay that on your piece of paper, maybe using the example on slide 14, maybe build your own example, and then build an intuition, build an impression of how the synchronized lockstep advancement of the left and right pointers lead to the implementation of the correct join semantics. All right. There's much more to be said on merge join. It's a very interesting algorithm. And since we are already, let me look, 23 minutes, I think it's the right point in time to just cut here and reintroduce and discuss all the details in the next video. I hope to see you there. Bye-bye.